1.7 for one day only. I won't see you guys tomorrow, don't forget. And then Friday, there's no school. So I won't see you guys until Monday. In between today and Monday is Friday at 11:45, which is when your AP classroom assignment is due. Please don't forget, guys. You don't want to get a 0 on something that's completion points, really. Okay. So 10 points, homework points for getting that done. Shh. I do not accept late AP classroom stuff. I'm giving you a full week. I gave you a whole class. Hey, guys, please stop talking. I give you a whole week and a class period to do it, so it needs to be done. Okay. So whatever you need to do to remind yourself. Okay. All right, so in 1.7, we're talking about something called rational functions, okay? Rational functions are a very specific type of function. Like a line is a function, a parabola is a function, a cubic, little S-looking graph. Rational functions have a polynomial on top and a polynomial on the bottom. And as we should know by now at this level of math, you can never have a denominator that equals 0, ever. Okay, so your denominator can never equal 0. Well, guys, polynomials have variables in them, like x squared plus 5. That's a polynomial. And if you have a x in your denominator, you have to say what x can't be because it would make the denominator 0. Like, for example, if I had like this polynomial, that's an example of a rational function, a very simple one. But you would have to say that x can't be -1, because if x was a -1, you'd have a 0. So anything that makes your denominator 0 shows up in a graph as a couple different things that we'll get deeper into on Monday, but they're called vertical asymptotes and holes. Well, there's something else called a horizontal asymptote and a slant asymptote that you're going to learn about today. I mean, you've probably learned about it, but I'll remind you about it, okay? To find horizontal and slant asymptotes, you look at the degrees of your numerator and denominator. So how many times have we used that word? We need to know what degree means, okay? Degree is the biggest exponent that you have. So if I give you, let me make one up here. If I give you this polynomial on top and this polynomial on the bottom, that's an example of a rational function, okay? To find a horizontal asymptote, now let me remind you what an asymptote is. It's an imaginary line that you almost always can't cross, okay? And it's kind of going to be like an abstract idea at the moment until we literally get to the homework and I do the first 4 homework problems with you where we finally see what a graph of one looks like. But just for now, understand a horizontal asymptote is a horizontal line that causes like a break in your graph, okay? And let's just talk about how to find those, okay? So there's 3 different situations or cases. If the degree of your numerator is less than the degree of your denominator, which is what we have here, right? 1 and 2. 1 is less than 2. Degree on top, degree on bottom. Then the line y equals 0 is the horizontal asymptote. So no matter what, if you have a 10 on top and a 27 on the bottom. If the top is less than the bottom, your horizontal asymptote is y equals 0. By the way, y equals 0 is the x-axis, okay? Y equals 0 is the x-axis, horizontal line, okay? Memorization. If the numerator's degree equals the denominator's degree, let me give you another one. So in this situation, 2 equals 2. So when the degree of the numerator equals the degree of the denominator, the ratio of the leading coefficients is the horizontal asymptote. Guys, ratio is just fancy talk for a fraction or division. Like a rational function is a ratio of 2 polynomials, okay? So all you have to do here is say, okay, 2 equals 2. So my horizontal asymptote is going to be my numerator's leading coefficient over my denominator's leading coefficient. And you always simplify it. 8 over 2 would be 4. Okay? Don't forget, if there's not a number in front of a variable, it's a 1. So there's one in the homework. I had a few people say, like, in that situation, that would have been 1/2, right? 1 2. Okay. And the last one is, thank you, we're on page 79. When the degree of the numerator is greater than the degree of the denominator. So let's call it. When this happens, so 2 is greater than 1, right? 2 is greater than 1. The graph has no horizontal asymptote. I'll tell you, this second case where they're the same and you take the ratio of the numerator and denominator's leading coefficients, students get that right all the time. It's the first and the third case that students mix up. Think about your own brain, what's going to help you memorize that. You want to memorize that because these tend to be pretty simple questions. It's like a multiple choice question, which is the horizontal asymptote. So you just want to be able to easily know the difference between these two situations. Okay, so come up with something that will help you, or talk to me and I'll try to come up with something. So whenever there's no horizontal asymptote, you could have a slant asymptote. Okay, now I'm going to read this and then I'll translate it to English for you. If the degree of the numerator is exactly 1 more than the degree of the denominator, then you will have a slant asymptote. The equation of the slant asymptote is y equals the quotient without the remainder when the numerator is divided by the denominator. Sorry, I have a Zoe in my place so that I'm going to talk to her and okay, so here's the thing. The minute we see that we have no, the answer is no, then we have to check for a slant asymptote. How do we know if there's a slant asymptote? If the numerator's degree is exactly 1 more. So if the numerator is 4 and the denominator is 3, right? Numerator is 10, denominator is 9. Numerator is 100, denominator's degree is 99. Okay, not that you'd ever see that, okay? If the top is exactly 1 more, then you will have a slant asymptote. So, for example, if you had 4 on top and 1 on the bottom, you would still say no HA, just like these are all no HAs, but you also would have no SA, okay? You wouldn't even have a slant asymptote, all right? So just understand that it has to be this exactly 1 more. And here's where long division comes in. You might remember this from Algebra 2. We have to do long division to find our slant asymptote. We're literally going to divide these two numbers. Just like we divided 8 over 2 and got 4, we're going to divide that by that. So just as a reminder, back in, you don't have to write this, back in like elementary school, I don't know, 4th grade, when do you do long division? I have no idea. When you had to do this, you would say, and you haven't had to do this for a long time, so you're probably like, what? 4 goes into 9 2 times, and then remember you multiply 2 times 4 is 8. What's the next step? Subtract. What's the next step? Do you remember? Bring down. Okay, so it's kind of in there somewhere, and you'd start all over. 4 goes into 13 3 times. Multiply, subtract, bring down, and you keep going until you have nothing left to bring down. It's the same exact steps for the most part, okay? So let's set it up. X minus 2 is your divisor, and x squared minus 5x plus 4 is what you call your dividend, although you'll never have to, like, repeat that for anything. And getting started is usually the hardest part, so let's just make sure we pay attention to this step, and that is just looking at the first term of your two polynomials. That's this guy and this guy. And ignore everything else. Don't even think about them. And you ask yourself, what can I multiply x by to get x squared? Right. X times x is x squared. But where you put that x is important. You don't put it above the x squared. You put it above the like term. Okay? So you find his family member, which is another x to the first power, and you start your problem off right by putting your first part of the problem in the right place. And I'll tell you why that's so important as we go. So I did that part. And now I do the multiply step. I'm multiplying x times x minus 2. I don't need to see this work, but if you need to go off to the side and show it, x times x minus 2, it's just a distributive property. I'm doing x times x is x squared, and x times negative 2 is negative 2x. Okay, the biggest mistake students make is right here, the subtraction step. We are going to subtract x squared minus 2x from x squared minus 5x. With polynomials, that simply means change both signs. You just change their signs. You'll hear me just say change the sign. So this one's positive, becomes negative. This one's negative, becomes positive. It's that simple. If we did it right, those should always cancel, and then you just subtract or add these, whatever. So that would be negative 3x. Okay? If there's something to bring down, now is the time. And then we start over. This is, again, where students get lost. Remember, they're because you're subtracting the whole thing. So understand, so let me just show this in case other people are confused. We have x squared minus 5x, and then I just put under it x squared minus 2x, right? The subtraction step is subtract all of it, right? So that ends up changing this guy's sign and this guy's sign. But instead of having to write all that, you just think, okay, my subtraction step is just going to be change their signs. If they were negative, they become positive, positive become negative, okay? All right, now remember our very first step was looking at the first terms. Well, we still always use this guy, but we're done with that one. This is our new first term. So you just start over. What times x gives me negative 3x? Negative 3. So I'm going to put negative or minus 3 right there. And then I do my multiplication step again. If you need to write it out, that's fine. I don't have to see it, but I'm just going to distribute. Negative 3 times x is negative 3x, and negative 3 times negative 2 is positive 6. Here's that step I was just talking to Gio about. If you're negative, you become positive. If you're positive, you become negative. And that's where the colors kind of help. You can see the changes I made. So those guys cancel, and I'm left with negative 2. Now, that's like technically a remainder, okay? But we don't care about the remainder for a slant asymptote. The slant asymptote is a line minus the remainder. So it's just y equals x minus 3. You will always get a linear equation for your slant asymptote. Because remember, the difference between them is 1. That's why you get a linear, okay? You would not get a linear equation if you did whatever this problem would have been. You would not have gotten a linear equation, okay? Now, we won't see what these look like till next week. Just understand there's a asymptote that's not horizontal, it's not vertical, it literally slants like a line, and it puts the graph pieces of the graph called branches in different quadrants, and you'll see that more next week, okay? All right, next page, let's just apply what we just learned. Example 1 and example 2. Find the HAs, provide a reason. I'll show you what I mean by that. So guys, if you don't have an x, you can think of that as an exponent of 0. Anything to the 0 power is 1, okay? So that's a 1 on top. So your numerator is 0, your denominator's degree is 2, 0 is less than 2. That's your reason, okay? That's showing that, okay? What's the HA going to be when it's less on top than the bottom? Y equals 0, okay? That's that first case. If you look back at your notes, you may have to look at it a few times. If the numerator is less than the denominator, and if you just write 0, it's wrong. You have to write it as a equation. Y equals 0. Hey. Okay, so 1 on top, 1 on bottom, of course, equals. So you would have 3 over 1, which is just 3. Always simplify a fraction. 3 over 1 is just 3. And lastly, numerator's degree is 2, denominator's degree is 1. 2 is greater than 1. What's our HA? None. Would we have a slant asymptote? Yes. It didn't ask us to find it, so we're not going to bother with it. But since this is 1 more than the denominator, we could have done the long division and found it. But just to practice it, we'll do one of example 2, just to do one more long division together, and I just put 1 in your homework, okay? I'm not trying to kill you with long division. Let's just do this one. So you can see 2 is greater than 1, right? 2 is greater than 1, so you know there's no HA, but we will have an SA. And in these directions, it said to find the SA. So we're just going to go ahead and do that. So x plus 2 and we start by looking at the first terms. And you ask yourself, oh, I forgot to mention it. The reason it was so important to line it up, look, if you're doing it right, all of the terms line up with their family members. So by starting it out correctly, look, all my x's are lined up. All my constants are lined up. That will happen every time if you did it right. Remember, constants are numbers without letters, okay? All right, so what times x gives you 3x squared? 3x. So decide where to put it, find his friend. Yeah. Okay. You started off right, the rest becomes a lot easier. If you need to go off to the side to do this, feel free. Or maybe you can just say 3x times x is 3x squared. 3x times 2 is positive 6x. So GO, these are both positive. I'll change them to negatives, right? Change both signs. That's the subtraction step. 5 plus negative 6 is negative 1. Bring down. And start over. You're starting over. Always this guy, but now a new one. What am I multiplying x by to get negative x? Remember, if you're lining things up correctly to begin with, there's a hint that you should notice that where I'm going to put my answer is right here with the constants. So I should know, without looking at that, but this could help you, that the number I'm going to pick won't have an x, right? It'll just be a number. So what times x gives me negative x? Negative 1, right? So then I'm doing negative 1 times x plus 2. Change both signs, and we get a remainder of 1. But we don't even care about the remainder. Your slant asymptote would be y equals 3x minus 1. You throw the remainder away, whatever you got before that. Okay? So, not fun. Maybe you think it's fun. I don't know. But it shouldn't be too difficult. This is where you want to be neater than you normally are. If you're someone that's really messy with your signs and stuff, you don't want to like lose a negative. All right, last page. Okay, so what we're going to talk about in our last example is end behavior with rational functions. Okay, so let's first find, well, I told you at the beginning of class that sometimes horizontal asymptotes are called end behavior asymptotes. You might hear that when you move up in calculus. Find your end behavior asymptotes, because your HA will affect what that is. It's not going to make sense to you until we get to the homework. These notes are not great in this section because she didn't give us graphs. But this will make sense when I explain it to you. You'll be fine, I think, if you understood the last couple of days. And then I'll get to the homework and show you an extension of that. Okay, so first is this. So what we want is the end behavior of this function, okay? But we're going to start out by finding the HA. All right, so I'm looking at these two, right? And I see 5 is greater than 3. When the numerator is greater than the denominator, what is my HA? None. And I wouldn't even have a slant asymptote. Okay, anytime your horizontal asymptote, you don't have one, we have to fall back on what we've already learned to find our horizontal asymptote, which is, let's take those leading terms and simplify it. Just those, okay? Meaning simplify this little fraction. 2 over 1 is just 2. And what do we do with the exponents when we are dividing variables? Anybody remember? We subtract, okay? So this is what we're working with. And now you just follow the rules that we have been talking about all week, which are, if you are even, you're going to go in the same direction, right? Up, up, down, down. And the positive 2 tells us we're going to go up, up. That's it, okay? So let's write our limit statements. The limit of f of x as x approaches, and you can choose to do negative infinity first or positive. You don't have to keep writing left and right. This tells me you mean left. If you're going towards negative infinity, that is to the left, okay? So you don't have to keep writing that. You can if you want to. But remember, that's how we start out every single time. And we already found it. On the left, we're going up. On the right, we're going up. Be careful. We've seen the last few days that sometimes polynomials are not given to us in the right format, okay? So leading term does not mean line leader. Leading term is whoever has the biggest power. So don't fall into the trap of, well, 3x came first, that's what I'm going to use, okay? So to find my HA, I see 4 is greater than 1. What's my HA? None again. So I have to fall back on simplifying this guy. Negative 5 over 1 is negative 5. And x to the 4th over x to the 1st is x to the 3rd. Odd means opposite, right? So it's either going to go down, up, or up, down. Remember, we think about a line anytime we see an odd. If a negative slope, my line would fall left to right. So I know immediately my end behavior on this rational function will rise on the left and fall on the right. So be super quick, because I'm about to teach another problem in the homework. Limit of g of x as x approaches negative infinity. See how many times we've been doing limit statements in the last few days? And I told you it's something that we're really particular about on the AP exam. So make sure you know how to write them. Then for the rest of the year, it's not even an issue on my test, on the AP exam. I mean, it's not hard, right? On the left, we're going up. On the right, we're going down. Okay? That's what you do when the HA is none. But what do you do if the HA is an actual number, like y equals 0, or y equals 4, or 1/2? That's where we don't have notes for it. We'll do it in the homework together. Page 82 is where the homework be. And I'm going to do 1 through 4 with you, and they take about a minute to do, like literally. So get that copied down so you can jump right in. All right, 1 through 4, there was no examples in the notes, so I'm going to teach you right here. Asking for limit behavior or end behavior and what the HA is. We're going to start with the HA, okay? So number 1, find your degree of your numerator, degree of your denominator, make your decision. When the top is less than the bottom, what is our HA? Equals 0, okay? So here we don't actually depend on anything other than this. Remember I told you HAs, horizontal asymptotes, are sometimes called your limit, your end behavior. It's because if you look at this graph, you guys, and don't let the vertical asymptotes there's a hole there, we'll get to that next week. What I want you guys to notice, this is important, look, there is an imaginary line there, okay? And these are your branches of a rational function. And look, as I go to the left, if that horizontal asymptote weren't there, this would keep rising up, and we'd say positive infinity. But the 0 is blocking me. I'm approaching 0. I'm getting really close to 0, but I'll never go past it. A horizontal asymptote blocks how high or low you go on your graph, which is what comes after the equal sign. Look at it from the right. As my graph goes to the right, I have something blocking me. I can't go down any further. I'm only approaching 0. I can't go any further. You can't touch that asymptote. It's hard for our human brains to comprehend that this arrow goes on forever but will never reach 0. The numbers just get so small that the human brain can't comprehend it, or our hand can't graph it, of course. Okay? Let's look at another one. 2 equals 2, right? So whenever that happens, you look at your coefficients. So that's y equals 3 over 1 or 3. Look, it's even graphed for you. Going to the left, what am I getting really, really close to? 3. Going to the right, what am I getting really, really close to? 3. That's why we call HAs our end behavior asymptotes. Okay? Again, 2 equals 2. 1, 1. So when the degrees are the same, you look at those coefficients. Okay, see it? Going to the left and to the right. We can't go past the 1. Degree 2, degree 2. 2 over 1 simplifies to 2. You can see it right there. Going to the left, going to the right, we're being blocked. We can't go all the way up to infinity or down to negative infinity because that asymptote stops you. So we're approaching 2. As x approaches negative infinity, y approaches 2. Okay? All right. I will put the rest of the cue up. Read the directions, do what it says. I just want you guys to stay with me next period because there's a kid in my class. I wrote 3 referrals for him yesterday in one day. I did. He told me I was stupid as F, but he actually said the word. I was like, oh, okay. Who's taking this class for the 3rd time? I'm wondering.